Ever since I was a kid, I've always loved sci-fi. And what pulled me into the worlds the most were the props. Whether it was the lightsaber from Star Wars, the Pip-Boy from Fallout, or a communicator from Star Trek. They inspired wonder, and one thing that they all had in common was they were reflections of their time. So I was born in the 90s, where things were more mechanical and interesting. We had physical media, like this. And most of all, we had different devices for different purposes. And as elegant and as beautiful as this was, it was still durable and fun. And as time progressed, we still had the same feeling, but a little flatter. Then one day it all culminated into a single device. It's what I'm shooting this video on. It's how I wrote my script. It's a cold, efficient, colorless rectangle. Now, don't get me wrong. I love how far we've come as a society, and I feel like we're closer than ever to reaching the stars, like in my favorite sci-fi. But it's just one device. And I want to do something to bring some of that sci-fi magic back to life. And I want to do that by creating a tricorder. And it starts with this. So I started sketching, but I felt I needed more inspiration. So I went into a deep dive into various sci-fi universes, and then eventually I decided on a traditional tricorder. So the tricorder is a device in the Star Trek universe that scans for three things: biological, environmental, and geological data. So I made this prototype out of foam to get a rough idea of the size. Now, a tricorder is a fictional device, and it detects sci-fi stuff that we can't really do in the real world at the moment. I believe I can do at least two of those things and add some extra cool features along the way. We're gonna do that by creating different modes. So we're gonna have environmental, which will do humidity, temperature, UV, that sort of thing. We'll have a measure mode that'll measure the distance between me and where something else is, as well as act as a compass. And then we'll have thermal imaging, we'll have sound, so we can look at audio waves as well as record sound bites. And then we will have a Wi-Fi and Bluetooth scanning mode. Now, adding this all into one clean package is gonna be a little difficult, especially for me, since I've never done this before. So here's the plan. Here's a diagram of how things are gonna be laid out. And apologies, I didn't have time to paint it or make it to scale. Now, all the raw data is gonna come in through the sensors. There's gonna be a lot of sensors, so to make this simpler for myself, I've added a multiplexer, which you can think of as the post office. It gathers all the information and it knows where it needs to go, and it tells the microcontroller where that information needs to go. So the microcontroller, which is our next stop, is where I'm going to load software onto to both interpret the data and output it to the user, which is me. So that's gonna go through the software, and that's gonna be connecting to our user interface, which is the speaker, the LEDs, the display, and the 8x8 matrix, which is gonna hold all of our animations. So this is the idea. Let's see if we can execute it. So this is by far the most money I've spent on a project, and you'll see why. I haven't worked on any of this stuff since I was in college, so I had to invest a lot in all the new components. So basic stuff like resistors and capacitors, but also all of the sensors and other modules that I'm gonna cram into this thing. So after I tested that everything was functional, I decided to move on to some soldering. For this project, I'm using the ESP32, which is a microcontroller that acts as the brains of the whole project. I'll be able to load a firmware onto it and get data from all the sensors. Now, I don't want to solder directly to the microcontroller for two reasons. I might want to use it for another project in the future, and it could break. So I want a way to easily swap it out. So I'm using this breakout board. Now, this means I need to add some power terminals to it that'll take in 5 volts. So I thrifted this old backup camera, and I think it's pretty cool because when it's in night mode, it allows you to see infrared. But it also has some infrared lights, which is perfect for testing this infrared sensor on this module. You can also see how often your face is blasted with infrared rays every time you try to open your phone. So after testing all the modules individually, I was able to mock up the first iteration of the software, which will switch between different sensors. Now, this was great as a proof of concept, but will definitely need a lot of improvement. A huge staple of sci-fi are blinking lights and cool animations. So I'm incorporating this 8x8 matrix, which does require a bit of soldering, but will allow me to cycle through different animations based on the modes. If you're familiar with soldering, you might have noticed that throughout the video, my technique changes a little bit and I do a bunch of things wrong. But working on this project has actually taught me quite a bit. A big mistake I always made was heating up the solder and not the pad. But what I think's made the biggest difference was switching to a leaded solder. But anyway, what I'm doing here is making a more permanent solution for the charging module, as well as creating an on and off switch from the battery control module to the 5-volt rail on the breakout board. After that, I soldered some JST connectors to the TFT screen, which will in turn connect to the proto board and go to the ESP. So as mentioned previously, there is quite a lot of soldering in this project. I have another proto board that's gonna hold all of the buttons to navigate the interface, as well as an LED bar that unfortunately I couldn't make individually addressable because the pins are at full capacity. Once that was done, I was finally able to make my first prototype. So like a lot of people out there, I'm a big believer in CAD, cardboard aided design, because it allows me to quickly throw something together to ensure that everything fits, as well as have something to hold and reference throughout the whole rest of the project. And honestly, there's something a little satisfying about throwing something together with cardboard. All right, so I don't know what the voiceover has told you, but here we are with the finished prototype. Now that I know that it all fits inside this enclosure and I know where everything's gonna be sitting, I can actually work on soldering up some connectors to the rotary encoder down here. But now that I'm holding it in my hand, I feel a lot more comfortable moving forward. So let's continue. The next thing I needed to do was design an enclosure on Fusion 360. So you'll see in a second that this first prototype turned out terribly. It was way too big, and because I used pictures of my components as reference points, they weren't terribly accurate. There was also a little bit of warping because I didn't position it right on the plate, but I knew I wasn't going to actually use this, so I didn't bother making another one. Now, despite its flaws, it actually gave me a great starting point. Now I know everything fits together within this larger container. I can scale it down and make something a little more sleek while still maintaining the same positioning for all the components. And I found out shortly after designing that first prototype that I could actually download the individual 3D files for each component, which was a surprising advantage to using Adafruit. So after printing, I removed the supports and started testing out how well the components fit in their slots. This first print was actually pretty snug, and a few of them started to break, quite explosively. But that's to be expected. So I took notes on everything that needed changing and got right back to CAD. Now, there wasn't a whole lot to change, so I spent a little more time on the flip-up lid by adding a ratcheting mechanism into it. One thing I've learned about the building process is there's always going to be issues in the transition between your computer model and the physical world. And all you can really do is try to fix as many problems as you can in each iteration and hope a new one doesn't pop its head down the line. Now this one had some glaring issues, but at this point I was getting so much closer because now all the components fit perfectly and I'll only need to make some cosmetic adjustments. So for what felt like the millionth time, I assembled everything, observed what fits and what needs adjustments, and took down copious notes. I also printed the caps for the buttons and the power switch out of TPU, which thankfully turned out pretty well on the first try. Unfortunately, during the course of this project, I happened to make two mistakes which coincidentally happened at the same time. The first mistake was bending the connectors on the display, which ended up ruining the solder joints. And the second mistake was connecting the 5-volt power from the charging module to the 3-volt lanes on my breakout board while the computer module and my sensors were connected. So when I sent that 5-volt on the power lanes, I thought I ended up burning out over $200 worth of sensors. But in reality, I was pretty lucky, and through a little bit of testing, I found out that it was just the display that was malfunctioning, so I ordered a new one. But not without trying to do a little surgery on the old one, which ultimately failed. But let me know down in the comments if you've ever tried to fix some solder joints. So after the screen arrived, I decided against using connectors and instead soldered some wires directly to it. This was mainly to save on space in the newest design. So I assembled everything for what I thought was the final time, but I actually ended up switching out the enclosure for one that was slightly different. So let's just skip right past that. Now we get to the software, which was arguably the most difficult part of this project. So I sketched out how I wanted the UI to look, what all the buttons were gonna do, how the sensors will interact with the LED bar, the LED matrix, and the speaker, and started coding everything all by myself from the ground up. I'm just kidding, of course. I'm still learning a lot about code, and doing it myself would have taken months. So what I decided to do was lean pretty heavily on Claude, which in my opinion has given me the best results when it comes to code. It also allowed me to add way more features than I initially planned. So stay tuned to the end of the video to see everything that this little thing can do. But the reason why it was difficult was because of all the troubleshooting I had to go through and figuring out if it was a software problem or a sensor problem. But thankfully, the board that holds the screen also has an SD card, which made extracting logs and troubleshooting a lot more simple. But once I got the software figured out, I could focus on the final touches, which included the sound effects that the tricorder is going to make, and finalizing the animations for the 8x8 matrix. Now, this is heavily inspired by Star Trek, but to ensure I'm not infringing on any copyright, I decided to make my own sound effects. For this, I used 11 Labs. They had this free tier where you can create different durations of sound effects, including some looped ones, which was really useful for the scanning modes. For the LED matrix, I found this awesome tool online that allows you to quickly map and code your own matrix animations, which I found super useful. And just like that, it was done. So here it is, a fully functional sci-fi scanning device. A device with a purpose that has multiple functions, but beeps, flashes, and has a mechanical feel to it. Now, you've already seen the outside and the close-ups, so let's see what this thing can do. First up, we have thermal mode, which means you can pretty much point this at anything and see the heat coming off of it. Then we have environmental mode, which detects temperature, humidity, VOCs for air quality, and UV. Next, we have measure mode, which will give us the distance from here to an object over there, as well as give us compass headings and detect color. Then we have the sound mode, which will show you the audio waves in real time and also allow you to record logs like a certain starship captain. We also have a Wi-Fi and Bluetooth scanning mode, which will show you all the different sources around you. Then you have a files mode, which allows you to save and capture data from any of the other modes onto the local SD card. It also has the ability to host a web page on the device that you can access from your phone, so you can download logs or any of the snapshot data. Now, you've probably also noticed the little animations up top that change based on the mode that you've selected. Using the rotary encoder, you can cycle through each sub-mode to decide which animation you want it to show, like the compass. Now, you probably noticed I skipped one, bio. Back at the start of the video, I mentioned that a tricorder does 3 things, and I could probably only pull off 2. And bio is the one that I skipped now, and that's mostly because of cost. Now, as cool as this is, it's not perfect. The battery management system is a bit janky. Occasionally, the device won't turn on unless you plug in a charger. And that's because this battery management system was actually made for a power bank. Now, that would probably be at the top of my fix list, which brings me to what I would do next. The thing I'm excited about the most is learning how to design and build my own PCBs so that I could make everything that I put in this fit in a much smaller pack. I'd also love to get that bio mode working, which I would probably accomplish by using O2 sensors and a heartbeat sensor. A standby mode would also be really cool, which means it would stay initialized instead of booting every time. I would accomplish this by adding a software switch in conjunction with the existing physical one. And then there's a bunch of smaller improvements, which would be noise isolation for the speaker as well as the rotary, and a way to push files and firmware updates over the Wi-Fi rather than having to plug in physically to the microcontroller inside. Now, if you have any ideas on how I could improve this, leave them down in the comments below. I read every single one and I would love to hear the feedback. Now, that would all be for a future project though, because this one took a few months to make and a few more months to edit the video. My goal is to keep making things that interest me and share it with the community of people who like the same things. So I'm putting everything up for download for free, the code, the STL, and the shopping list. It's all gonna be linked down below at peyotelabs.com. Right now, at the time of posting this video, this channel is not monetized at all. So if you wanna stay up to date with what I build next, or you just wanna support the channel, subscribing, hitting that like button, and that bell icon will help tremendously. But that's it for now. As always, thank you for watching, and I hope you have a great rest of your day.